Alright, g'day nerds, how we doing? So today we're going to look at the electromagnetic spectrum. You'll see here that we've got the sun, and what we've essentially got is a rainbow. And there's not a true rainbow of colours, but these are what different parts of the sun look like using different types of light, which we'll see in a minute. They all exist on the electromagnetic spectrum. So our learning goal is to basically understand the electromagnetic spectrum as light of varying wavelengths, and that the light we can see, which we call visible light, is just a small subset of that whole spectrum, which we'll get to that in a second. By the end of this, you should be able to relate the properties of a wave, so like its wavelength, not so much its speed, but that shouldn't change, and its frequency, to the idea of the color or type of wave that we're looking at in the electromagnetic spectrum, that is. So what is visible light? Basically, all the colors that we know of combine to form white light. White light's basically made up of all the colors, and we can split it. And you may have seen this sort of picture before. And if white light goes into a glass prism, we can actually split it into its different types, and that's also how you get a rainbow. Blah blah blah. White light from the sun hits the water droplet, and it bends. And as it bends, it spreads into a different wavelengths. As we see, here's the wavelength for red light, orange, yellow, green. And as we can see, the frequency of these waves is the wavelength of these waves is getting shorter as it goes from red to violet, or the frequency is getting higher because they have that relationship. So as wavelength goes down, frequency goes up, and as frequency goes up, wavelength goes down. And we can demonstrate this by bending light. Again, we see that as white light from the sun hits a water droplet, and it turns into a rainbow, which is what we've got down here. And each one of those different lights is a different, not just one wavelength, but like a range of wavelengths. So there are a bunch of different types of different reds and oranges and so forth. And here's the rough wavelength. So you've got 400 nanometers. That's a billionth of a meter, so 400 billionths of a meter. That's how long the wavelength for light is. 425 billionths of a meter. That's your indigos, right up to your reds, where you're at, say, 670 to 700 billionths of a meter, or nanometers, are your red wavelengths. And infrared, which we actually feel as heat, we can't see it, but we feel it. Infrared is longer wavelengths than red. It's the next type of light after that. So just to show us that relationship again, this is the properties of waves, right? So wavelength is the distance there. Speed of light is 300,000 kilometers per second, or 3 million meters per second. Okay, so this point of energy right here will travel 3 million meters in 1 second, and that speed's constant. That doesn't change, and that's in a vacuum again. Speed changes in different materials, but for each density that it'll go through, it is constant. And we've got the frequency, wavelength, they're related to color. Amplitude is the distance here between the sort of from not crest to trough, from the neutral point through to the crest or the trough. That's the amplitude, and the larger that is, the brighter the wave, or the brighter the light. And so here we have a different type of wavelengths, right? So you've got invisible light, it's just this small section here. And we go right up to radio waves. So we can go right up to radio waves here. Now, see, it starts smaller and smaller. There's your gamma rays, X-rays, ultraviolet. So your UV light, which is the light that can cause skin cancer, to X-ray light, these guys, they are shorter in wavelength, higher in frequency than visible light. Infrared, microwave, so I don't know why that keeps skipping, 10 to the minus 2. What that means is that wave is centimeters. It's in the centimeters range, like 10 centimeters thereabouts. Radio wave is 10 to the 3, which means it's hundreds of meters, no, 1,000 kilometer long. you need to be a building to pick that up. Alright, solved that problem. Not sure what was going on there. Well, I'm sure I solved it. So anyway, this is where we're at, right? So visible light is 10 to the minus 6, right? Really, really small. Here we have infrared, microwave, radio. It's getting bigger and bigger and bigger. Again, that's 10 to the 3 meters. So that is about 1 kilometer, which means you actually need quite a large aerial. And that's the sort of thing we're talking about, right? So here's humans. Yeah. I didn't solve that problem at all. Anyway, what we can see is that the wavelength of light affects the type, right? We can only see this small section here, and that's because that's about roughly the size of our eye cells that will pick it up. And we also see that each wavelength of light is emitted at a peak range of temperatures. Alright, I hope that made a lot of sense. If you have any questions, put them in the comments below. We'll get back to you as quick as we can. Thanks for watching. See you next time. Bye now.